This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the October-November 2022. This is the Statistics S1 paper. This is paper 5, variant 1. And in this question, we are told about a large population. The systolic blood pressure, SBP, of adults is normally distributed with a mean of 125.4 and a standard deviation of 18.6. We're going to find the probability that the systolic blood pressure of a randomly chosen adult is less than 132. So we are basically, we're told that we have a normal distribution here. So let's say the systolic blood pressure, let's call this X. So we say that X is distributed normally. The mean is 125.4 and the variance is 18.6 squared. Mean variance, that's how you write it. Now, we want to find the probability that X is less than 132. X is less than 132 in a randomly chosen adult. So we want to find this probability. Okay, so we have to basically do some standardization. We have to standardize the score such that it becomes something which is able to be modeled in the normal distribution curve that we have in our tables. Okay, so we have to basically find how many standard deviations this score is above or below the mean. And you do that by simply standardizing the score. So to find the standardized score, we take the number, the value that we have, we subtract from it the mean, and we divide the standard deviation. Okay, so in this case, the Z value is going to be X, which is 132, minus the mean, which is 125.4, divided by the standard deviation, which is 18.6. 18.6 squared is the variance. Okay, so this will give us the standardized score. So we can take the calculator and we can standardize the score. So we have 132 minus 125.4 divided by 18.6. We put the standard deviation, not the variance, we don't square it. That gives us 11 over 31, which is 0.35483. 0.35483. So we always write the standardized score to 3 decimal places because that's what we can use the table up to. So 0.355 is what we have to look for. So that means our standardized score is above the mean. Of course, it's above the mean, as you can see. 132 is above the mean. But this is how many standard deviations it is above the mean. Too big, 1 second. All right, so what we're going to do is we're going to put a little mark here. That's the score, 132. That's the X value. Okay, the Z value we're looking for is 0.355. That's what we're going to look for in the tables. And we want to find the probability that Z is less. So basically, we want to find the probability that Z is less than 0.355. In fact, we could have done this in one step. In fact, I'll do that better. We could have just written down that Z, the standardized score, is equal to the score minus the mean over the standard deviation. And then we could have just said this means that the probability of X is less than 32 is the same as the probability that Z is less than, and then we standardize the score, 132, the score minus the mean, 125.4, divided by 18.6. Okay, so we can say that's the same as saying the probability of Z is less than, and still got my calculator now, 0.355, okay, to 3 decimal places. 0.355, that is what we're looking for now in our table of values. So we go to the normal distribution table and we look for the value of Z of 0.355. So I'm looking for the probability that Z is less than 0.355. So how do we use this table? Well, 0.3 is here. So I'm going to go up to here, 0.3. And then 0.35 will be here. So we're looking for this number here. But we have one more decimal place. So now we're going to go to this 0.35. We go to 5 over here and we see where does that reach, where does that lead us to? That 5 takes us down to that 19 over here. So I've got to deal with these two. So I'll put 0.6368 plus, and that's 19. That gives us 17, that's 8, that's 3, that's 6. So our probability is 0.6387. Okay, so we're going to have, this is equal to 0.6387. So we can write this to 3SF. 0.639 is the probability that X is less than 132. And that is the answer to question number 4, part A. Okay, now for part B, it says the blood pressure of 12-year-old children in the same population is normally distributed with a mean of 117. Of these children, 88% have systolic blood pressure more than 108. Find the standard deviation. So now we can say here that let's call this now for the children. Let's call this, I'm going to call this Y, for children. So we can say that the blood pressure for children is distributed normally with a mean of 117 and a variance that we don't know. Standard deviation squared, we don't know. Okay, and we have, again, our normal distribution table or curve, which will help us to picture what's going on. And we know that the mean is 117. That's the Y value, we called it Y. And the Z value would be 0 for where the mean is, that we're standardizing the score. And we know that 88% have a systolic blood pressure more than 108. So that means, of course, that 88% of the people are above that value. So the 108 is going to be on this side of the mean, as we can see from the numbers we have anyway. So that's 108. And we're looking for this part being 88%. So we have this as 0.88. Okay. So we need to look at the table of values, all right? But the table of values, I mean, we need to look at the areas now. We don't look at the Z values, we look at the areas and the probabilities, okay, inside the table. We look for 0.88. But what we have to understand is the Z value that we're going to find when we look for 0.8 will be, 0.88 will be somewhere over here. It will be the mirror image, okay, of what we're looking for. So the Z value that we're looking for, which is this Z over here, let me call it Z1, and let's call this Z2. Okay, what we're going to find is the area to the left of this Z value, which is the opposite sign of this Z value. This is negative 1, this is going to be a positive Z value. Right? So if I search for this in the table, I will find the value of Z over here. What we want is the opposite sign of that value. Okay, because we want to have the Z value on the negative side. The table doesn't give us that. So if we go back to the table and we now look for 0.88 in the area section. Okay, in the area section, 0.88. What's the closest we see to 0.88? Well, it's either this or this. Okay, so if we go down to here, 0.8790, and we choose that, we choose this, and then we go to the 10 at the end. If you add 10 to this, that's going to be 0.88. So I'm looking for this combined with that. So this will be 1.17. So that's 1.17 1.17, and then we have to add, and then it's going to be a 5, 1.175. 1.175, okay, because that 10 there added to it will be a 5 there. So we're looking for the Z value of 1.175. That's going to be the Z value that is on the opposite side, but we want the negative version of that. Okay, so if we go to the question that we've done, 1.175 is this. 175, that's what we just found. Because they don't have the negative Z values in there. So what I'm going to do is I'm going to say, okay, this is going to be negative 1.175 because it's a mirror image. Okay, so I know that the Z value that I'm looking for is negative 1.175. So if we look at the standardization, we have Z equals X minus the mean over the standard deviation. In this case, we know the score, which corresponds to the standardized score. So I can say minus 1.175 is equal to the score, which is 108, minus the mean, which is 117, over the standard deviation, which is going to be solved now by rearranging this formula. Okay, so the value of the standard deviation is going to be 108 minus 117 divided by negative 1.175. So therefore, the standard deviation will equal, we have 108 minus 117 divided by negative 1.175. Okay, and that will give us our value, which is 360 over 47, or 7.659, 7.6595. 7.695, let me see, 6595. 6595, sorry. Wrote that all around wrong, nice. 6595, let me do it properly. Okay, so we want to write this to three significant figures. So we can say the standard deviation of this distribution is going to be equal to 7.66. Okay, that's the standard deviation for the distribution. And that concludes this question, I think. No, it doesn't. Then it says 3 adults are chosen at random from this population. Find the probability that each of these 3 adults has SBP within 1.5 standard deviations of the mean. So now we're going back to the adult population. And now for part C, it says 3 adults are chosen at random from this population. So we're looking at the adults now. And for the adults, we had this situation over here. Okay, so I'll take that. So for the adults, we had the situation that the blood pressure was normally distributed with a mean of 125.4 and a variance of 18.6 squared. Now, it says here, find the probability that each of the 3 adults has a blood pressure within 1.5 standard deviations of the mean. Okay, so basically, if we take this. Okay, I like to take this already drawn, it's much easier. Okay, so now, within 1.5 standard deviations of the mean. So here's the Z value, 0. This is now, we're looking at the Z values. And 1.5 within 1.5 standard deviations of the mean. So that means basically between minus 1.5 standard deviations up to 1.5 standard deviations. So between Z values of minus 1.5 up to 1.5. So we're looking for this area over here. We're going to find the probability that Z is, we could say, between. So the probability that Z is between minus 1.5 up to 1.5 standard deviations above the mean. So basically what that we already have it standardized. So what we could do here, what I would do here, I want to find this area, this area between these two. I would find what this area is first. Okay, this is like finding the probability that Z is, what I would do is this, the probability that Z is between 0 and 1.5, okay, between 0 and 1.5, and doubling it. So this is finding the probability that Z is between 0 and 1.5 and doubling it. Okay, so it's 2 times this area here. So how do I find that? So 2 times the probability that I'm going to find the probability that Z is less than 1.5. Okay. And I'm going to take away from that 0.5. Why 0.5? Because a half of this area is 0.5. The whole area is 1. So if I do the probability that Z is less than 1.5, and then I subtract from that 0.5, I've subtracted all of this, I've only got this part then. That will leave me with just this section over here. Okay, and then when I double it, I get the area that I want. That's my way of doing it. We can do it in other ways. We could have found the probability that Z is less than 1.5 and taken away the probability that Z is less than minus 1.5. That would work as well. And then you'd have to basically find, you do the probability that Z is less than 1.5, and then you take away from that this area over here, which would be the same as that area over there. I think that's more complicated, so I will do it this way, to be honest. So I'm going to do 2 times the probability that Z is less than 1.5. Now, so I'm going to look for this. So I'm going to go to my table of values. I'm going to look for 1.5. So where's 1.5? All right, so the Z value of 1.5, if I go to 1.5, that's going to be over here, 1.50 basically. So we have 1.5 and we have 0. So it's going to be basically 0.9332. 0.9332. Okay, so we got that value, 0.9332. So this is 0.9332. And then we take away from that 0.5. That will give me this area over here. When I double it, it will give me the area that I'm looking for. Okay, so this will give me what I'm looking for here, which is the probability that Z is between minus 1.5 and 1.5. Let me write that a bit neater, sorry. The probability that you got Z between minus 1.5 and 1.5. So we'll put this in our calculator. So we have 2 times 0.9332. Okay, put that in a bracket. Let me do it this way. 2 times 0.9332 minus a half. Okay, in brackets. So that will give me minus 0.5. That gives me the answer, which is 0.8664, 0.8664. Okay, and what we have to do is, that's the probability of one person chosen at random. We want to find three adults chosen at random. So basically, our answer is going to be 0.8664 cubed. Okay, first person, then the second one, then the third one, all of them have a standard deviation, has a blood pressure within 1.5 standard deviation of the mean. It's going to be given by this. So we take our calculator and we take this and we raise this to the power of 3, and that gives us 0.65036, 0.65036, which the 3SF is 0.650, and there's the answer to question part C, and that completes this question. And there we are. Okay, so that completes this question. Other questions from this paper can be found in the playlist on the top here for this paper, Other questions from the topic of normal distribution you'll find in the playlist down here. You can subscribe to my channel by clicking on the link over there. And on the top, you'll see a link for a video which tells you how to use my channel effectively. Thank you for watching and see you soon.